So earlier we saw BPT theorem. Now we are going to see the converse of BPT theorem. To understand the converse of BPT theorem, let's recall first what is BPT theorem. So what BPT theorem states is, if there is a triangle and a line intersecting two sides of the triangle which is parallel to the third side, that is, if DE is parallel to BC intersecting the other two sides of the triangle, then AD by DB is equal to AE by EC. That is, the intersecting line divides the other two sides. The parallel which is parallel to the third side divides the other two sides in the same ratio. That is what BPT theorem state. So now the converse of BPT theorem is, if a line intersecting any two sides of a triangle, if there is a line intersecting any two sides of the triangle such that it divides the two sides in the same ratio, then the line will be parallel to the third side. So we already have this. Now we need to prove this. That is, DE is parallel to BC. That is what we are going to prove in converse of BPT theorem. That is converse of Thales theorem. So first let's see the converse of Thales theorem statement, and then we proceed with the proof of the converse of BPT theorem. So the statement is, if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So to see the proof of this theorem, to understand the proof of this theorem, let's consider a triangle and mark the respective points. Let me consider a triangle ABC, and there is a line which divides AB and AC in the same ratio. So let me consider a line which is DE. So this DE divides AB and AC in the same ratio, which means AD by DB is equal to AE by EC. And this line DE is not parallel to BC, okay? But it divides AB and AC in the same ratio. That is, we are assuming the contradiction and we are going to contradict the proof. Okay, so here we assume that DE is not parallel to BC, but DE divides AB and AC in the same ratio. So now we are going to consider another line from D to AC. Let me mark this point as F, and this DF is parallel to BC. That is what we assume. We assume DE is not parallel to BC. We assume DE is not parallel to BC, and we also assume that we draw another line DF which is parallel to BC. Okay, so now what you can say, that is, since DF is parallel to BC, by Thales theorem, that is by BPT theorem, we can say that AD by DB I made a mistake here. Okay. AD by DB is equal to AF by FC. Okay, let me mark this equation as 2, and this as 1. Okay, so we got this two equation, and from this, using this two equation, we proceed with the proof. So consider that same figure and mark the respective points A, B, C, D, E and F. And we got already two equations. The two equations are, what is equation 1? Equation 1 states that AD by DB is equal to AE by EC. Okay. And equation 2 states that AD by DB is equal to AF by FC. So from these two equations we can tell that AE by EC is equal to AF by FC. So what you can tell now? Add 1 on both sides. We just going to add 1 on both sides of the equation. So AE by EC plus 1 and AF by FC plus 1. So when we take LCM in numerator, we are going to get AE plus EC by EC and AF plus FC by FC. So after adding 1, we are going to get AC by EC is equal to AC by FC. So this can happen. This can happen if and only if E and F coincides. E and F coincides. So which absolutely means that since E and F coincides, we proved that E and F coincide, which absolutely obviously means that DE is equal to DF. So which again means that since DF is parallel to BC, DE is also parallel to BC, which is a contradiction since we assumed DE is not parallel to BC. Hence, our assumption is wrong and DE is parallel to BC. So we proved that if a line divides any two sides of the triangle in the same ratio. Here DE divides AB and AC in the same ratio. Then the DE will be parallel to the third side, that is BC. Hence we proved the converse of BPT theorem. I hope you guys understand the converse of BPT theorem. So like, share and subscribe Easy Math.